You think you're slick.
Well, I'm
uh,
lying down, so.
I'm gonna have to lower it a little bit. Is everyone in it? Looks like it. All right, perfect. So let's get started.
This is. I am laying down right now. That's why I'm so short.
Uh,
Eh,
so,
there we go. Time to just chillax for like 2 hours.
oh, this is a fun class.
Yeah, I
We're gonna
already
be
saw
going
that.
over math chips.
Math.
Uh, hope y'all love math,
Strings.
strings, and booleans. We kind of went over booleans a little bit. Not really though. Okay. Let's start with we do strings. Oh no, let's do booleans. Oh, and one thing before we start, I'm gonna ask everyone to try to keep your questions on topic. You know, if we're talking about booleans, please make sure your question is about booleans. That way we can get to the like free time after you guys can build stuff, and then feel free to ask the question then, because you know we're open to whatever then. But when we're teaching the class, please try to keep your questions on task. Okay, so here are pretty much all the boolean chips. Everyone remembers what a boolean is, right? From yesterday.
Mm-hmm.
Yep.
Mm-hmm.
All right, great. They are pretty straightforward. Uh, so does anyone remember what this does? We did teach it yesterday. Anyone want to, Potential Wolf? You want to explain what it does?
Yep. It's
Go for
just
it.
basically. Are you talking like the variable in like in general, or just like
Do it. What does this do? What is a variable?
variable? It just saves information, and a Bool
Exactly.
variable in general means that it will save information whether the input is true or false.
Yeah. All right. So let's start off with our first chip. This is called a OR gate. The way of how it works is it takes multiple inputs, and you can actually configure this chip and click add more inputs, and you can have probably up to 64 or 65, I'm guessing. Uh, and the way of how an OR gate works is if any of the inputs are true, it'll output true. But if all of them are false, it'll output false. Does that make sense?
Mm-hmm.
Okay. This is a AND gate. The way of how this works is if all of the inputs on it are true, it'll output true. But if even one of them are false, it'll output false. Um, and you can also add more inputs to this one. This is a NOT. What it does is it just flip flops the boolean. So if you give it a false, it'll output true. If you give it true, it'll output false.
Mm-hmm.
That that's it. um, all right, this is a equals chip. You'll notice the input of it is white, meaning that it can take a any input. If you hover over it, it says any. For the most part, that's what white means. Um, you could put two of anything in there. It could be a number, it can be a boolean, it can be players, it can be objects. Whatever it is, if they are identical and the same, it'll output true. And you can add more inputs to equals as well. Do you want to add
I'd
something?
just like to take this moment to explain the difference between equality by value and equality by reference. So if you give it something like an int or a float or a string, any of those primitives we talked about yesterday, it will check if the value, if like the text in the string or the value of the number is equal to the other number, for example. However, if I give it an object, like for instance, like a button or a light, or a trigger handle or whatever, if I give it two trigger handles, which are configured the same, that will still give you false, because when it comes to objects, this is checking for equality by reference, which means it has to be the same object. Now lists sort of are objects. That's why you have to store them in variables. But the equal chip does have a special case where it will actually check all the elements of the list and make sure that they are equal by value. So basically lists and like data, whatever, those are all compared to see if it equals the same thing, like if it is the same information, whereas objects that you like look at in the room or players, for instance, those are checked that they are the same instance of the object.
Yep. Everything on the inputs need to be the same. It'll kind of force you to. If you were to connect one Boolean, the other port will switch to a Boolean as well. If you make it a player, they'll both become player ports. You couldn't check if a float and integer were the same number. That's not possible. You could convert it, I guess. Okay, next we have. We'll do greater than first. If the number in the A port is bigger than the number in the B port, then it'll output true. And if it is not bigger, it'll output false. Greater or equal would mean that whatever's in the A port needs to be bigger than whatever's in the B port, or equal to whatever's in the B port. In this one, if they're the same, it'll output false. And then same thing for less than whatever is in the A port needs to be less than whatever's in the B port. And those are the equal then one. We'll do parse bool. What parsing is for pretty much everything is a way to convert one thing and try to get data from it and turn it into another thing. So here we're parsing for true or false. So there's a string here. If I were to type true into it, the result would be true. If I outputted false, the result would be false. And you'll notice it says parse success. That's because if I just type straight gibberish in there, I don't type true or false, then there's no actual true or false to parse from it. So this will be false. Whether the result will probably still be false. Ignore the result if the parsing success is false.
In general,
Okay.
the parse chips, if it does not successfully parse, it will be the default value. The default value for bools is false. For ints and floats, it's 0. For strings, it's the empty string.
Yeah. For things like, actually, you can't parse. No, that's too complicated.
Yeah,
My bad.
whatever.
Okay, over here.
Do we have a question? One, yeah, what's up?
How could parse bools be used for something? Like an example.
So for instance, if you have a prompt player chip where like you hit a button and a prompt comes up and they can type something in on their watch, they could type like true or false in, and then you could put that back into your logic somehow. Of the parse chips, like Bool is probably like the least useful. But like broadly, there are a bunch of parse chips which will be helpful.
Yeah, if you guys look up parse in your maker pen, you'll see there's a way to parse numbers like floats, integers, color. Color is actually really cool because with color you're able to type in like red, blue, or whatever, and it'll match it with the rec room color. Or you could type a hex code, which y'all can look up what that is if you want to know. Okay. Any questions before I move on to these two? But these two are pretty straightforward. Nope. Okay. So a if chip. Well, actually, does anyone just not know what an if does? Because if not, I just won't even bother. You know? Okay, I'll go for it. All right. So what an if does is if the Boolean here is true, then when you run this chip, it'll output on the then, like output. If it is false, it'll output on else. That's all it does. It's super simple, although it's super useful. You'll probably use an if chip a lot. Yeah. And then an if value is similar to an if chip, but it's also really useful. If I were to take, ignore the chip I'm using, I'm just doing this to make the type a integer. You'll see I can put a Boolean for then or else. And what happens here is if this is false, it'll output whatever's in the else port on it on the output. And if this is true, it'll output whatever's on the then port. So I could put like a 1 in there. 2 in there, and so then if
Oh,
this
okay.
was true, it would output 1, or if it was false, it output 2. Does that make sense? All right, let's move on to some more chips. Next up, we're gonna do some math. So I hope y'all paid attention.
Wait, we're not doing Nan and Or?
Snug, do you want to talk about the ones on the left? I'll just go over them real quick. So there's, yeah, could you bring those back? You probably won't use these chips much. This is nor or not or, NAND or not and. This is basically equivalent to taking an or chip and then putting the output into a not chip. It's just the opposite of if you ran this through or. NAND is the same thing, but with and, just and then into a not chip. You can also, like all three of these, you can configure them and add ports to it. There's also the XOR or exclusive OR. Of the three, this one's probably the most useful. This will look and make sure only one of them is equal. Like when you have an OR chip, if you have A and B that you're checking in the OR, if A is true, it will the output will be true. If B is true, it will be true. Also, if both of them is true, this will be true. But on exclusive OR, only one of them has to be true or can be true. So either the first one or the second one. You can configure to add more ports. You probably won't have to do that anytime though.
We put them off to the side because we don't.
Yeah,
ever
they're
really
not
use
too
them.
important.
Yeah, but I guess they're good to know. All right, let's go into some math. Ooh. A cool thing about the math chips is that if you paid attention in school to math, you'll actually be able to apply a lot of the stuff. So Will, do you want to do it?
Sure. Okay, so first of all, we have add, multiply, subtract, divide. I'm guessing you all probably know what this does. If you would like clarification, just ask me after. Notably, they do work on both ints and floats. Also vectors on some of them. Quaternions as well, though I wouldn't recommend that. You can configure these and add values on, I know you could do it on and, can you do it on subtract? Oh,
You
I
can
think
do
all
it
of
on
them
all of them,
support, yeah.
even
Cool,
remainder.
so oh, cool. So
Oh,
you
wait, why do we
just
have?
basically do what you'd expect. We have absolute value up above. Basically what this is if you imagine a number line, so there's 0 in the center, all the positive numbers are out to the right, all the negative numbers go out to the left. Absolute value just means how far you are from 0, from the origin. So if it's negative, it'll just give you that number, but like if it were positive, so -5 would be 5. And if it's positive, it won't be changed at all. Down here we have power and root. If you have ever done like exponentials in math, like 2 to the whatever, that's what a power chip is. This is like the base number here. So if it was like 2 to the third, this is the 2, and then this would be like the 3, and then it would give you 8. I believe this also works on both ints and floats. Yep. Root. This, you give it one number, and then the root. This is the root. So when you spawn it in the room, the root actually defaults to 2. So that would be a square root. So if I give this like a 2 up here, and then this defaults to 2, the square root of 2 is like 1.4, some irrational number. But if I gave it like 4, square root of 2, or square root of 4, that would be like 2. Up here we have modulo. This is actually very useful, especially if you're dealing with indices of lists, which we talked a little bit about yesterday. It basically is the remainder of like a number and then some multiple. So if you think about like 5 divided by 2, that's 2.5. But like how many times does 2 go into 5? So you multiply 2 by 2, that's 4, and then you have 1 left over. So if I did 5 modulo 2, this would give me a 1 because there's 1 left over after you go up to 4. So this can be useful if you have, for instance, a list. Like maybe like a common use case you see this for is if you have like an audio player and you have a list of songs, and then you have an index. It's like an integer variable of which song you're playing in the list. So it starts at 0 for the first element in the list, and then you go up. But if you increase that index too far, you get past the end of the list. Like there's no way to get that song because like you've reached the end. But if you use a modulo chip and you do your index modulo the length of the list, then when you get to the end, it will loop back around and it will give you a 0 to start back at the beginning of the list. And then as you keep going, it will just loop that over and over again. Same thing works if you go the other direction, like if you go down, if you get into negatives, it'll just loop you back around to the top of the list. A few more over here. We have, we'll start with min and max. If you give it 2 numbers and it gives you the bigger one, I believe this works with ints and floats. Yep.
I think you can
All 3 of
configure
these
it.
too. Yeah, that would make sense. Yeah, you can configure it, add ports, so you can give it a whole bunch of numbers, and it will give you the biggest one. Similarly, min gives you the lowest number. Clamp is kind of a combination of these two. You give it a value, like say I give this like 0.5, and then a min and a max. So this is the lowest it can be, this is the highest it can be. And if it is lower than the minimum or higher than the maximum, it will clamp that value, give it to be within that range. So if this is like, if min is like 0 and max is 1, and I give it -1, it will clamp it back up to the minimum and just give me 0 as the result. If it's already within that range, it won't have a difference. If you give it values that don't make any sense and your like maximum is lower than your minimum, I think it just gives you whatever you give it as the minimum, but that's kind of an error case. So these chips here are pretty useful for dealing with like ints and floats. We have seal, this is short for ceiling. This will round it up. So imagine I give it like 1.5 or 1.2 or whatever. It will round it up to the next whole number 2. It will still be a float. It'll be a whole number, but it'll still, like the format, like the type of the port is still a float. If you want it to be an integer, however, since like it already like fundamentally is like a number that is mathematically an integer, you can use seal to int. This will do the same thing. It'll round it up to the next whole number, except it will return it as an int. There is a chip int or is float to int? Oh, I guess never mind. I'm confused. So there is round to int. This will just take any number and round it to the closest one. So if I give it like 1.2, it'll round it like 1 is closest. 1 is closer than 2. If I give it like 1.9, it'll be up to 2. And that will return it as an int. Round is similar, except that it returns it as a float. And then we have floor. This is similar to seal, except instead of going up to the ceiling, it goes down to the floor, goes to the closest whole number that is below it. And there's an int and float variant. Going the other direction, you can convert an int to a float. Like all integers, like this set of integers are contained within the set of floats, so that you don't really have any like data loss there. So I give this like 1 or whatever, it would return 1 as a float. Down here, we have a couple random chips, random float and random int. You'll notice these have execution ports, which might seem kind of odd given that we don't have XX on any of these other ones. But the way it works is you run it, and they have, like both of them work the same. They have a minimum and a maximum. Both default to between 0 and 1. So on the float, if I run this with a 0 minimum and a 1 maximum, I'll run it. And then this value port here, this will be some value between that, maybe just like 0.4 or whatever. Probably have a bunch of numbers after it because it's completely random. This value will stay here until you run it again. Any chip that has an exec on it and a data port out, when you run it, it will update the value of that data port, and it will stay that value until you run it again. This is different from chips that don't have exec ports, in which like the way these work is every time you try to access this port, it will update it. It will go back through the graph and update it in real time as you're accessing it. Whereas XX stay the same until you run it again. And this is random, so that like that is like desirable on this kind of chip, because otherwise it could just be like changing every time you access it, which could be kind of weird. Cool. I think that's everything for those. Anybody have any questions?
Where's the remainder chip?
So there is a remainder chip. It's similar to modulo. It has slightly different behavior for negatives, so we don't really need it.
Yeah, gotcha.
Just use modulo.
Yeah.
Is it a beta chip or no? Modulo? Beta chip?
I think
It's
I
not.
recently took it out of beta.
Oh, thank God.
All right. Can you take these chips back? Next up,
Sure.
we're gonna be going over strings. Ooh, this is the last thing before we'll move on to an example. All right. This is basically all the string chips. Does everyone remember what a string is? Okay. Uh, so first up, we have toString. This takes any type of port. It could be an integer player object. Don't really do object. It's kind of lame when you do it, but you can. It'll output like the type of object. It'll be like maker pen object or like piston or whatever it is. And outputs it as text or a string. And next up, we have string format. This chip is super useful. It's kind of confusing at first, although like it'll make sense. And I recommend that you guys place down your own string format because the best way to understand how this one works is to use it. Unless you guys already know how to use it. So first of all, you can configure this and add as many ports as you want, up to 65. And the way of how it works is you type a format up top, and then you can reference other boxes. So if you wanted to reference what's inside of this first port, you would write, where's my chat? Right there. You would write curly brace, 0, curly brace. Like this. Looks like that. That is a curly brace. And if you added another port and you wanted to reference the next one, you would do curly brace 1, curly brace, and just counting up 1, 0, 1, 2, 3, 4. And this is useful because you could do something like this. Get the local player. Then toString. And then connect that right there. And then in the formatting, write like hello, and then
Is there
the
any
name.
other CNC classes that teach you advanced circuitry or no?
So if you guys were to
I'm
hover
sure
over
there
this
are plenty
output,
of them,
Will,
but I
mute your
don't know
mic.
of any by name. Oh, I thought I was. It said I
Yeah,
was.
I don't know either. I couldn't find it in the Recrum server.
I don't know, maybe the voice shall have to say. If you guys hover over this, you'll see it says hello and then your name. For me, it says Snug. It says hello, Snug, but you know,
You can still hear
for
me.
yeah. But like if autocost, if you were to do it, it would say hello autocost on the output. Does that make sense? How to use it?
I know someone who
Okay.
can independently
It's
teach
super
us
useful.
advanced circuits.
Is the voice roll off really high in here? Because I'm hearing everyone.
Probably. Can you hear me?
Yeah.
10.
Yeah.
What the Sorry about that.
I'm
I
still
I did the
here.
mute option, just like regular, and it said everyone is now muted, which it doesn't usually do.
That's a different command. You sure you did the right one? We have
Maybe not.
mute. Mute does it for everyone. Teacher Mike does it just for you.
Oh. Okay, I might have hit the wrong one.
Okay, so hold on. Now everyone can one of you guys talk?
Yeah.
Yeah.
Okay, so now it's really high.
Hello.
How about now? Now it's
Yep.
even
Help.
worse.
What? Help.
What?
Hello? Talk.
Hello.
Okay, that's how it should be. No one touch it. It's right now. Okay. Let's move on to string concat. This is kind of a newer version of string format, and I think it's a little bit more efficient than string format, but I could be wrong about that. If you configure this, you can add more ports, and what it does is it will take whatever's in the first value, and then put whatever's in the separator, and then put the next value, and then put whatever's in the separator, and then put what's in the next value. So, for example, I could put hello in the first one. Then in the second one, put snug. And I can make the separator just like a space. And then I'll get rid of these extra ports. I don't have to, but. And then what this will do is it'll go hello space snug. And then I could add another port and it would be space and whatever's in that port. It's super useful. And this is essentially doing the same thing that I have here, but you know, that won't work for every single use case. Okay, next up, let's do string length. This one's super fast. It tells you how many characters are in a string. Any questions on that? Okay. List contains. What this does is you give it a string and then you give it something to search for. If whatever you're searching for is in that first string, it'll output true. Keep in mind it has to be it is cap sensitive, I'm pretty sure. So if you put like your name in one but then had it on all uppercase in the second one, it won't match because it's cap sensitive. String index of, kind of the same idea of string contains. You give it a string, then something to search for in that string. If it is in there, it'll give you the index of, I'm pretty sure, the first digit of it. Yeah. And if it's nowhere in there, it'll output -1. Yeah. Okay. Next, we'll do string replace. Kind of similar again. You give it a string, something to look for, and then if it finds that, it will replace it with whatever's in the replacement. Yep. String trim gets rid of the white space at the beginning and end of a string. White space is like a space, a down space, and like tab. I'm pretty sure that those counts as white space. So if that's at the beginning or end of a string, I'll just get rid of it. It'll clean it up. Next we have string substring. This one, you give it a string, then you give it an index, meaning like where you want to start in the string. So if I gave it an index of 0, it would be just at the very beginning. It'll have the whole thing after it. But if I gave it an index of 1, it'll actually cut off the first digit in there. I mean, it'll skip it. And then the length is how much after that I want to have. So if I write apple in there, and I do a index of 2 and a length of 2, it'll just output PL because it's skipping the first 2 digits, so then it's on P, and the length is 2, so it's only getting PL, and then it's not going to E. That makes sense? Okay. Now let's go over to these. These are list things. String split at index. You give it a string, you give it an index in the string, like where you want it to be, and it'll split it into 2 items of a list. So it'll make one element of this list the first half, and then the second element of the list the second half, based off of where you split it. String split. You give it a string, you give it something to look for. Every single place it finds it, it will split it into a list, and it'll also get rid of it. So if I had a list of players, for example, or like a list of like fruits, apple, banana, pear, and I separated them with like commas or something. So apple, comma, space, pear, comma, space, banana, right? And I made the divider, comma, space. It'll get rid of the comma and space and separate each item. Does that make sense? Mm-hmm. All right, that's a pretty useful chip. String split white space. It'll split wherever there's white space. So if there's a space, tab, or down space, it'll split it and make a new element in a list. Okay. String upper. It'll take a string and output it as every single thing in there as uppercase. Obviously not numbers. There's no such thing as a uppercase number, but like anything that can be uppercase will become uppercase. Same thing for string lower, it'll make everything in it lowercase. And over here we have some parse chips. This is what we were talking about for parsing. We have a few cool parsers. The cool ones are at the top and bottom. Parse time and parse color. I already talked about parse color, how you can type in a color, which is super neat. But parse time, you could give it a date or you could give it a time and it'll output a universal second. Universal second is a standard way of like getting a specific time. It is how many seconds it has been since 1970. Couldn't tell you why. That's probably when they set the standard, but it is how many seconds it has been since 1970. So, since we don't go over time in any other class, do you guys want me to explain time chips right now or just move on? Do you guys get it? Yeah, you want me to? Okay, I'm getting a few people saying it. It's pretty straightforward on how to use it, but it is super cool if you guys want to have like a clock or something. So we'll get just the like basic. It's actually a whole tab in your maker pen for time, which is kind of cool. Is that everything? I think that's everything you need. Okay. So here's your time crash course. Oh, Speedy.
Oh, isn't those are the chips that people use when they're making a daily reward system?
Yeah, actually, you would use get universal second, and you would add however many seconds are in a day to like a integer variable. So you would get this plus however many seconds are in a day, set it in a cloud variable, and then if the current universal second is greater than the number in that variable, then you know it's been 24 hours. Does that make sense? If you want, I can show you later. So up here we have get universal time. Notably, this is in central time. This is not your time. So if you hover over it, it shows the current year, month, day. The year and month are probably right. I guess there's like on New Year's, it's probably not based off your time zone. And it'll show all this stuff not in your time zone. The seconds, right, I guess. All right. Then we have time get universal second. Like I was saying, this is how many seconds it has been since 1970. Keep in mind, and this is super useful, this number is the same for all of us. So if we wanted to make a counter, we could mark down the start time, like the time in here in like a synced variable, and then subtract that number from the current universal second, and that number will count up and it'll be the same number for all of us. Yeah. All right, next we have player get time zone. This is your like time zone difference in seconds. So if you were to add these two together, you would get an outputted like number, and that'll be in your time zone. And a way to use that would be with the get formatted time. If you guys want to learn how to use formatted time, I highly recommend just going on to like Google and looking up how to use C#, so hashtag time formatting. If you guys forget that, you can actually go into your palette, look up get formatted time, and click the little I button, the little I icon, and it'll show you a short description. And in that description, it says return the given universal second formatted based on C# date time format. So that's how you'll know what to look up. Anyways, you'll connect
So
this
chip,
and this is out.
This chip is is actually like running like actual C# code because that's just what the game is made in. But if you find these like codes anywhere else, it's pretty much like a standard across all programming languages. So you'll probably see it in like JavaScript a lot because that's where like web development is, or Python, whatever. So if you just find like date codes like this, it'll probably work in this chip here.
Yep. So by default, this shows the hour in like military time or scientific time. I don't know, whatever you call it. And you'll see if you guys hover over this, this is your time. This is locally your time zone because we've added these two together to ensure that it's your time zone. For me, it's my time zone. For you, it's you. If I wanted to make this, who clicked on the chip? Can you? If you wanted to make this like AM PM, you would change the H's to lowercase, and then put TT at the end. That's for AM PM. Now, if you hover over it, it shows your time in AM PM. I just know that formatting because I've used this chip a lot, and you guys will learn it too. But if you ever forget, remember just look up how to use C# time formatting. Okay. Any questions about anything up here?
By
Up
the way,
here.
it's probably worth noting that the parse time is kind of the opposite of get formatted time. Although you'll notice that parse time does not take a format, and like it just takes the text string. That's because the chip will like do its best to figure out. It'll just like look at it and figure out which format you're using, so it'll kind of just work automatically.
Mm-hmm. And I'm pretty sure Wilcho made that chip, so he won't brag about it, but I will brag for it. Default, you have a question?
So in the get formatted time, what did you put in there again? You put
Right here. This is HH, which is like AM PM hour.
yeah.
If it was an uppercase H, it would be military time, but since it's lowercase h's, it's for 12-hour time. And MM is for minute, SS for second, and then TT, lowercase TT is AM PM. And I'll switch based off it. Question?
So, because I've made one of these before, but I didn't never include the SS. I've just always had the HH, MM, and TT. I've never really added SS. Does that really change anything in it, or is it pretty much the
No,
same
it
thing?
wouldn't. It would get rid of the second. Right now, this one's showing minutes. I mean, this one's showing hours, minutes, seconds, and AM PM. If you got rid of SS, it would just be hours, minutes, and AM PM. So it's not
Okay.
required. No. Uh, then this chip is also really cool because you can do year, month, and day, and it format. It's such a cool chip. So I highly recommend that you look up it. Question.
In the format I just put the letter F and it put like the day, the time, the date, and the year. And then that's basically what I was
Yeah.
saying. Just
Crypto.
Is it possible to hook it to a text so that a text would show your time zone?
Yeah,
Possible?
totally. So, since this is a string, the purple port, you could take a text and connect it to the set text chip,
Right, because you can connect the
right?
end.
Because remember,
Is
they're
this
both
like switching between
they're
a
both
fixed
strings. So you would just do
string
that,
string.
yep, and then take a event receiver, put it on like 30 hertz. You don't need it to be update because that updates way more. So update 30 hertz. And I'm not going to plug it in because there's something a very important step here. We have changed this text to be your local time zone. So like for me, it's my time, for you it's your time. So if this was a synchronized text, then it would be bugging out because we would all be setting this text to be a certain thing. And we will go over this in another class with more like being what is okay, well, thank you. But I'm gonna put that back. If I configure this and unsync the text, and then connect this 30 hertz, this is now your time in AM PM. Default, you have a question?
Nope. One second. hold
You
on.
don't? Okay, Seek, you have a question?
I was gonna wonder, what does that 30 hertz do when you configure that? Like, what is it doing?
So the update 30 hertz is sending a signal 30 times a second, give or take. Uh, and so in this case, it's just constantly sending the text. I see the questions, but Will looks like he really wants to say something, so I'll
So
let him.
this is an event. We haven't really talked about events yet, but we're gonna have a whole class on them. If you want to like check it out before then, basically you just put down an event receiver chip and you configure it, and you'll see all the built-in options. As Snug said, this one just sends out a signal 30 times a second. It might be a little bit slower than 30 times a second if you're on like a low-end platform like a phone or whatever. But 30 hertz is the max. You'll probably see this one a lot. This is generally just like what you use if you want something to just be running all the time.
This is not the best way to
And
do
what
this.
does
We
that
could have
delta
done this
time do
before.
when you do the 30
Oh,
hertz and it
yeah.
puts
So,
that
so
delta
we'll,
time
we'll
below
cover
it?
all this when we get to the event class. But the delta time is how long it has been since the last time it ran. Now, if it is running at exactly 30 hertz, that would imply that the delta time will be a 30th of a second every time. But computers aren't like exactly right when they do these things with timing. So this will like vary a little bit. If I like hover over it, like there's a little bit of variation. If you're on a low end platform, you can see like you can use that to figure out how fast it's actually running because it'll be less than 30. But if you want to like run something continually and you want that like, for instance, if you want like something to move forward on a 30 hertz, you should multiply how far it's going by the delta time because that will actually run it. It will move it a consistent rate for everybody, like whether or not you're running at 30 or not. Yeah, what's up, Frog?
No, I think they're typing. It's okay if I ask
Default, go real quick.
So, you were saying earlier, right, about it bugging out?
I think that one says just update. Oh, so there's one event called update. It's not update 30 hertz. That actually updates for every single frame on your game. And it's super useful. If you want something to move super smooth, you would use update. It's not consistently 120 hertz. And Will Chill made this, so I think he's more qualified to
Yeah.
speak about it.
If you're on like a high refresh rate monitor, you might get like 120 or 144, or like a console that's running at 120. It's literally just the frame rate of your device. So most of the time, it'll probably be like 60. If you're on just like a standard monitor or a phone or maybe your console isn't going at 120. Sometimes I think it can be like 30. Notably, VR headsets kind of have like unusual refresh rates. Like I think Quet's defaults to like 72. If you're on PC VR, you'll probably be either like 90 or you could go up to like 120 or 144. But it's just your refresh rate. There is also a delta time property on that one. That's the exact same concept. It's just how long it's been since the last time it ran. Sorry, what was your question, default?
So, kind of relating back to yesterday and also this today. You know how yesterday I was asking about, like, when I connect it or spawn in the invention that has the time saved, it would just bug back
Yeah.
and forth, like, trying to flash it. Is that because of what you were saying, where it tries to get
Yeah,
everybody's time?
so odds are your text was probably synchronized. And what happens here is this chip is running for everyone. So imagine all of us in this room trying to set that text, but then our time zones are different, so we're all setting it to something different. We'll go over this in the networking class, so I highly recommend that you go to that one. Yeah. One question.
I forgot my question.
Okay. Sadie the bunny, what do you? No question? Okay. Any other questions before we move on? We're moving on to a example, so that's fun.
I can do the
Pass
one
that
we
over
did
to
last
Will.
class, unless you had something in mind.
The one
Okay,
that
cool.
you were planning on doing.
Sure. Yeah.
Okay.
Okay, so something you'll see in a lot of rooms is, for instance, you want to pick some player. Maybe you want to like teleport them up on stage or whatever. Maybe you want to mute them or kick them from the room. And the way you, like a good way to do this is you have some circuit, maybe it's like a button, and you hit it, and then a prompt comes up, it's like a multiple choice prompt. You pick a name, And in that list, we want there to be the list of everybody in the room. We want to see their username there, and then we want to be able to pick it, hit OK, and then get a reference to that player in the room. So let's build something like that. First, I'll just spawn in a button to make it simple. Okay, so when we hit this button, the pressed exec is going to run, so that's where we can start. So let's take out the prompt multiple choice chip. We haven't covered this chip yet, but it does pretty much exactly what the name would imply. It prompts a player to pick a multiple choice selection. So when you look at it, there are a ton of ports on this thing, so let's just explain what they all do. There's the exec in, there is the exec out. This runs after you finish running it. There is the player. This is like when you run the chip, this is who is going to see the prompt. Most of the time, you'll probably just want to leave it on local player. There's a prompt title, prompt body, and the list of answer choices. Notice this is a list of strings because these are all the options you will see when you run it on the little like multiple choice menu. So for instance, for the prompt title, we could say something like select a player. So this will show up there on the menu. Cool. We can just leave body empty, but if you wanted to, you could say like, I don't know, like this player will be muted, whatever you wanted it to do. Notice this chip has two exec outputs. This one says run. This one says on prompt complete. This is one of a set of chips referred to as latent nodes, meaning you'll run it and immediately this top one will run like right after that happens. And then after some time, depending on the chip, depends how long it could be. After that, this on prompt complete chip like output port will run on the chip. In this case, you'll run it, this one runs, and then this one runs after they've made their selection. So it doesn't actually run until they hit OK or cancel or whatever their response is. So that's cool. That's these values won't get populated until they've made their selection. So that's when we can like know to run our additional logic. There's a success port. Like if they, for instance, hit cancel, the success will be false. Receiving player, this will generally be whatever player you run it on. Most of the time, it'll just be the exact same player. But like for instance, if you run the chip on like multiple people at once, by the time this one runs, you could have run it on a different player, so it needs to like tell you who actually this execution is corresponding to. You probably won't have to worry about that too much. The response is which item from this list of answer choices they picked, so that like when they run it, you can feel free to like spawn this in and like give it a list if you want. But it will tell you the string from the list of answer choices, and then lastly the response index. This is the index of whichever one they picked. If they pick the one on the top of the list, it'll be 0. If they pick the one after that, it'll be 1, and then all the way down to the length of the list. Cool. So now what we want to do is get a list of answer choices. This is going to be a list of strings, and where every element in the list is the name of a player. There are a few ways to do this. Any way we do it, we're going to need a get all players chip. So let's take this out. We used this briefly in the example yesterday, but just to explain what it is, this just gives you a list of all the players in the room, as the name would imply. It returns a list of players. Cool. So there are a couple ways to do this. One way you could do it, I could take out a 2-string chip, and if I just hook up the players to like the player list to a 2-string, it'll like automatically format all the players into one big list, separated out by commas, and there's like brackets at the ends. So we could take this list or this big string and like do some string operations on it to separate it out, or we could use something called a for loop, which I'm gonna put down. Let's use a for each even. So the way this works is you give it a list. This case, just directly into the list of players, and then you run it, and then for every item, for each element in that list, it will run the loop exec port one after the next. Like it'll happen immediately. Like you won't even be able to like perceive that it's happening. It just like runs in your circuits, and then it will set the item to that element in the list. So if I were to run this, it would run this for everybody in the room. It would run once for me, it would run once for you, for everybody in it. And then once it gets to the end, it runs the done port. So we probably don't want like ourselves to be in the list. So let's filter ourselves out. Let's take out a list except chip. We also used this briefly yesterday, but basically the way this works is it takes a list and it filters out every element that is also in the second list. So we just want ourselves. That's just like one item, but you'll notice the chip takes a list. So we can't just wire like local player into it directly. So we have to make it a list first. Let's take out the list create chip. And hook that up to the second port. And this has 2 ports by default. We only need one of them, so let's configure it and remove the second port. You'll notice that this knows it knows that the input port should be a player. So how does it know that? It looks at what it's connected to. So the first item it's connected to is a list except. Before these were connected, they would just be list any, like they would be like white list ports. But the way it knows that's a player is because it's connected to here. So this chip is literally like looking through the graph between the wires and the edges and figuring out what type it can be. This only returns players, so that defines what the types are for the rest of the chips. You'll see this port defaults to invalid player. Let's just click it once to make it local player, so that's us. So now the output of this list will be every player in the room except ourselves, the player who is running it. Cool. So now we want to take these and put them into a list variable, because that's the only way you can like make changes to lists is by saving it into a variable. Otherwise, it won't remember that you made that change. So let's take a list string variable, and I'll name this players, or let's name it names because it's actually going to be their names. Cool. So the first thing we want to do actually, because you can imagine like if you run this, you'd set all the names. We're going to load everybody's name into the list. And then if you run it again, and that's all you do, you'd be adding their names all back onto the end. So people would be in it twice. So the first thing we're going to do actually is we're going to clear it. Actually, there is a list clear chip. So let's use that. So we hit the button. Very first thing we're going to do is clear the list, and this has an input port for which list we're going to clear. Let's just hook that up to the variable. Cool. So we're going to clear the list, and then right after that we're going to go into the for loop, the for each loop, and for each player we're going to get their name. We can just use a toString here. This will give you their display name, so that's the thing you see over their head. Similarly, there's a chip to get their account name. That's like their @ we could very well just use that chip to substitute it if we wanted to. Let's just use their display names. And then we're going to use the list add chip and add that into the list. Okay, so we got some things set up. Let's reorganize a little bit so it's a little bit easier to follow. So the button, list clear, for list add, move this chip over here. Cool, so that's a little bit easier to follow. So now we're going to add everybody. We'll run it. We'll get everybody in that list. So that all looks good. Ooh. And then we can just take that once that's done, and we'll take the output, the current value of the names list variable, and hook that up to answer choices. So now when we run this chip, it'll prompt us with that list of names. So we need to like run this exec input. And where can we do that? So we run this. Like ordinarily, you might think we'd put it here, but this is going to run. This is going to run for everybody in the room. So let's just get the done port and hook it up here, because we want to wait until all of these names have been added, and then only once that is finished, this done port will run, and then we can use that to run the thing. Cool. So I just hit the button, and I'm seeing everybody's name here, except myself. That's all working as expected. You can hit the button if you'd like to see how that looks. Cool. And then we're going to have on prompt complete. Oh, that's all good. So what we can do here, let's just show them a subtitle that says hi. Let's take it a subtitle chip. Okay, so this is going to show a subtitle to some player. There's a player input port on it. We need to get which player it is. So this is going to give us the response and the response index. What we can do is let's just take the index and take that index, run it through the list to get the player directly. Actually, no, because we've accepted ourselves, so that could offset the index. Let's parse their name, and then we'll use their username and get the player. I believe this player by account name. Yep, or by display name, because we're using display names. So let's take this chip. This is going to take a display name, and then it will return a player. So let's run that player into here, and then when I run it, Snug, did you just see a subtitle pop up? I guess I haven't typed anything in yet, so it would be empty.
Yeah, it was blank.
Cool. So I've just made it say hello.
So, does everyone understand why this works? Why it does what it does? If you have a question about this, raise your hand. Nope. Okay. Then I think we can let you guys go out and build something. What should... Oh, I have a question.
Yes, to type.
Sorry. Yeah, go ahead.
Yeah, we'll also leave this up here for the rest of the class, so you can take a look whenever you'd like.
Yeah.
Okay,
What should they build?
So last time we did an assignment where we had a list of strings, and every time they would hit a button, it would increment a value using modulo, and display
Yes,
that
like a
text
clicker.
on a button or text. So very
Yeah, like a
similar
clicker.
to the clicker we did yesterday, except instead of incrementing the value, you're going to increment the index and then get a string out of a list and display that somewhere.
So, did that make sense, or do I need to explain it? Okay, so
You could probably
what
explain it later.
what you're gonna do is take a int variable and add a number to it every time you click, like the clicker we made yesterday, right? Now, the difference is after the add chip and before you put it into the variable, add a modulo, and make the second number on the modulo the number of elements in a list, right? This list, just make a list out of list create or something, right? And add at least 4 elements in it. It can be less, but like for this, just do more than 4, and write anything into the list create. Then you'll get the element of that list based off of whatever the number is in the integer, and then set it on a text. Now, to those of you who got it, go out, go find a spot and make it. To those of you who need more help, stay here and we'll help you guys one-on-one. So let's go find a spot. Oh, actually, let's get our photo before you guys go out.
Right.
Yeah.
Come up front. Make sure you're not flying. All right. All right. Go find a spot. Uh, all right. So do you are you guys the ones who still need help on what to do? It shows the first thing. Click it. Click the next thing. Click it. Shows the next thing. And once it gets to the end, it just loops around.